Hello everyone, today we're gonna talk about how to design a road or a highway using Civil 3D. First, you have to download those 4 files from the description. TCX Converter, Converter Sheet, Google Earth, and AutoCAD Civil 3D. First, we're gonna open the Google Earth Pro and go to our area, which is Sharjah. Our objective is to design a highway that connects Sharjah with Dubai from Maliha Road, which you can see. Here is the area that we want to build. This is Maliha Road and this is Arawir Road. We want to connect them with the highway that connects from 3 lanes. First select a path and start drawing a path. The path should cover the whole area. Then name the path as you want. I name it by contour lines. Click on OK. You see it will appear here. Hit click. Save places as. I'll put it on desktop and make the extension .kml. Click on save. And we don't need Google Earth, you can close it. This is the file we computed. Open TCX Converter. Make sure it's in an English language so you don't be confused. Click on open file. Locate the file we just saved from Google Earth. It's what's in the desktop. Click on track modify and update altitude. What this program do is it converting the latitude and longitude to the altitude from coordinates. Click on yes. Wait till the green light down pop up. It will start updating the altitude now and the green light pop up. Go to export and export .csv file. I'll put in desktop. Click on no because you want the comma delimited for the Civil 3D program. Wait till the green line comes and close it. Now we're gonna use this file to compute the coordinates and the altitude in our area. Open the file. From all this data, what we care about is the latitude, longitude, and altitude. First, we can open the converter sheet and we can copy the latitude and the longitude from that Excel sheet, so we can convert them to northing and easting. It's like converting the decimal degrees coordinates to the UTM coordinates. So I will copy the latitude and longitude. Over here. Then go to the last line, select all of it, and double click on the corner. Now you have all your data converted. Go copy the northing and easting. After copying them, open a new Excel sheet and paste them over there. Go down, click on the control word and make them 1, 2, 3. Only to copy the numbers. Now they have longitude and latitude and we need the altitude. So we go to the old Excel sheet. We don't need this anymore, we can close it. We go to this Excel sheet and copy the altitude from it. Make sure you don't copy the words, because the words, Civil 3D can't understand the words in the Excel sheet. Copy the altitude, put it near them, and now we can close this, we don't need it. And now we can save this as our final Excel sheet. I go to stop and name it as final. Contour lines. Make sure that the extension is .csv, delimited, because there is more than one CSV. For the Mac people, there is a CSV only for Mac. This is for Windows. Now we can see that the file appeared on the right. We can open Civil 3D. After opening Civil 3D, go to the main menu on the left top, open it, go to drawing utilities, and then to drawing settings. Now we'll set our exact coordinates in United Arab Emirates. Select the datum as WGS 84. It's always in the bottom. Then go to UTM North 40. Zone 40 North is our zone for UAE. And click on apply, then OK. Now, the point that we are in the middle of the earth, so we're gonna open the map, hybrid. The point that we are now in the middle of the earth, so the zone 40 is on the right, so we keep on shifting into the right till we see it. You can zoom to extent because they are not considered as an extent, they are considered as a background. Now we found the zone 40, we go to zoom to our area, keep on zooming till we find the area that we're interested in. This is Maliha Road and this is a highway road, and we're gonna connect them with the highway. Now what we need is to put the contour lines, so we'll go to home and create a new surface, click on OK. You will see a plus on the left appeared, click on it, click again, right click on points and add a new file, click on plus. Now click on final contour lines, click open. We agreed it's northing, easting, then the elevation, so click NEZ and OK. You will see the contour lines appeared here. Now to start designing, click on alignment creation tools, name it, click on center line, go to design criteria and choose your design criteria. Use base design and click on the elevation, make it 6%. OK. Click on the arrow, tangent to tangent with curves. I'll start my design from here till this point, and I will go straight to Al Awir Road. Each click is a curve in the program. You click on enter. Then you check your radiuses if they satisfy the minimum radius or not. You can see over here our radiuses, and here is the minimum ones. They all are right and correct. So now we have our alignment, which is our road. We can draw its profile. Click on this, we don't need it anymore. Go to profile, create a profile from surface. And this is our surface. Now click on surface, add, then we'll take right and left of the surface. So we click on your width, my width for my design is 1.5 here, 3.6, 3.6, 3.6 and 3, which is about 15.5. So I'll take 15.5 on the right and minus 15.5 on the left. Click on draw and profile. Now a new window will open. You don't if you want to add anything of those, you can add. It's not, and it's already here assigned. It's already here assigned. It's already assigned. Everything is assigned. Now you can click on create profile and view and choose the place where you want to place your profile. I click over here. You can get rid of the map. Now as you can see here, there are three existing lines, the middle one, the right and the left. To continue designing, we already have the profile now. We have to draw the vertical curves. So create a profile by layout and click the layout that we just have computed. You will see here design criteria, use basic design criteria, and the AutoCAD standards. Click on OK, go back to this arrow, draw tangent with curves. Now you can start drawing. Turn on the snap tool and start drawing. You should minimize the cut and fill. So let's just draw over here, over here, over here. And click on enter after you finish. Same as horizontal curves, you will get new data. You can check your radiuses from here if they meet the criteria or no. What we care about is this K over here. If your K value is equal or more than this value, you are in the safe side. So if you want to be more in the safe side, you can go for this basing distance, but it's fine to stay on the K value. Click X. Now after we finish the vertical curve, we can do our superelevation. How we can do our superelevation? Just go to your alignment, center line, and choose edit superelevation. Now you can calculate the superelevation. I will choose divided planar with median. Now for this type of designing, you should put your whole length of your right side and make it symmetric, because the maximum number of lanes are 2. So just click on one line. My total lengths are 5.5 with a -2 slope. Go to next. If you want a shoulder, I already included over there. If you want a new shoulder, it's fine. I won't calculate it. Here's the maximum 6% 2-lane planar roadway. Apply curve smoothing and automatically solve overlap. Finish. Now it start calculating. Click over here. Now we want to draw it. So you go to the alignment again and select it. You will see superelevation over here. Create superelevation view. Now it will give you some data. Just to change those colors so we can separate between them, the right and left turns. Click on OK and choose the place where you want superelevation to be drawn. Here's our superelevation. Now you see a lot of wrong signs. That means that the distance that covered by 6% slope isn't enough. So what you have to do is increase the runoff and runout distances. How you can do that? Just select over here, you will see some lines. Just extend them. And you will see the signs are going out. One over here. Now after computing the superelevation diagram, we want to draw our cross section. So you go to corridors, create assembly, basic and all codes. You can name it over here. Click on OK. Now choose the assembly where you want to put it. You can click over here. After clicking Contour 3, you will see this window appear. This window has a lot of designs and elements that you can use directly in your design. So I start by basic and put a basic barrier. Here is all the values from the code, from the highway design manual. You can see a new barrier appeared over here. Go up, go to basic lane, For me, the parameters of my lane, I'll assume that they are all one lane, so I'll put 12.5 without the shoulder, and here's a left, so you have to go to the left and put it over here. Now go to the right and put it over here. I'll assume my shoulder is 3 meters with a slope of 4. So we go to the right, zoom in, click over here, and go to the left, zoom in, make this left, and click over here. Now this is my cross section. Of course you can add a lot of pavement designs, a lot of sub-base, sub-grade, but because we don't have enough data to calculate, we don't have more knowledge to create structure analysis on the pavement. So we'll go for this for now. And now after finishing drawing your cross section, you have to add something called daylight. The daylight, I'll go to daylight standards. It's like when you have excess elevation over here or a very low elevation, it will make it as a standard and will fill it or will cut it depending on your values. So I'll put another one here, and we are done from the cross section. You can close this. Now we want to create a corridor for cut and fill. So go to corridors, create a corridor, and here is all your alignment is UOS, profile is layout 1, assembly is UOS, and the target surface is surface. Click on OK, and when you go to target, you should assign this as surface. Click on OK, and OK, click OK, and rebuild the corridor. Now let's start calculating over here all the corridors. It's fine, click on True, go back to your corridor. You should see a lot of amounts that go steep from here and steep from there. This is our corridor and this is our design till now. Now we want to know how much cut and fill that we have to put. Now to start calculating the cut and fill, we should know that we have two sides, top and bottom. Over here, if you have a pavement or something subgrade, the top are we call it a top, and the bottom we consider it as a bottom. When we go to corridor properties, now go to add a new surface, name it as top. The overhang here is top length, and go here and make a top and press and plus. Make a new surface, call it as bottom. The overhang here is bottom length. Go here, click on datum and plus. Go to boundaries, right click, add automatically. Click on daylight as it's your boundary of cutting and fill. And here you have your boundaries. Click on apply and rebuild the curve. So now what we're gonna do is we're gonna create a sample line. Click over here, right click, then click on this arrow, go to sample more sources, make sure you add all of those, click on apply, make sure you change this to finished and this to finished. Click on OK and apply. Now click on OK, go over here and click here. I'll choose my width to be 60 and 60, which is the right of way. Click on OK, and if this one to appear, click on OK. Now this line will appear. Go to the first station and right click on the first line. Now we're gonna calculate the cut and fill that we want. Go to analysis, compute materials, This is our alignment, and this is the only sample line that we have. Click on OK. Go to quantity takeoff criteria and click on Earthwork. Click on this existing ground. Make it as surface. And our datum is the bottom. Click on OK. And now it will start calculating the cut and fill that you need. And now after it finished calculation, you can go to total volume table. Here is everything set to default. You can choose the number of columns and rows that you need. I choose about 50 and click on OK. Choose a place where to offset your table. It will tell when you zoom in, you will find the total volume over here, which is about 1 million of cut and about 1 million for fill. The data are huge because maybe the content that accurate. That's the only reason. Now this is torque cut and fill in each station in your design. Now to create the cross sections on each station, go to sections. Now to create cross sections on each station, go to sections, create multiple section view. All the values are set to random. All values are set to default. Go to section view tables, total volume, basic, and add the volume. This is for cut and fill schedule that will appear in front of each cross section. Create a cross section and paste it over here. This is the final output data. You have all the stations with their cut and fill amounts on the schedule, and all cross sections and all stations from 0 to the point you have finished on. You can simply print them on PDF or use them from the layout. You can edit your page as a normal AutoCAD file. This is the end of the tutorial, and later on we may extend to giving tutorial of bridge design using the AutoCAD Civil 3D. Thanks for watching, and you can refer for me for any extra information.